Hello, my name is Chanel Domgia. I am an electrical engineer student at Temple University. In this video, I'm going to show you how I designed the processor data path that we did in lab 12 for the digital design class. So in order to achieve this goal, we're going to need to integrate the arithmetic logic unit ALU from lab 6 and the 2 read and 1 write from lab 11. We're gonna need 8 register and each word 4 word wide. We're gonna need for the operation we're gonna need a write data to register, a to read data from the register, and we're gonna need to perform arithmetic logic on register. So this is actually a small microprocessor design, so we have some limitation. So this is the operation process. So in order to write, we're gonna have to turn the switch 7 and the switch 3 off. The switch 7 must be on. This is the switch 7. This switch 7 must be on, and this switch 3 must be off in order to try. In order to read, we're gonna turn the switch of 7 off, and the switch 3 must be on too. And for the ALU, the switch 7 and the switch 3, the switch 7 must be off and the switch 3 must be on. So in order to write, we gonna have to manipulate the switch from 0 to 2, and it's gonna show in digit 0 and 1. The digit 0 is going to correspond to the memory address, and the digit 1 is going to correspond to the data. So, and in order to save the number into the memory of the board, we're gonna have to press the left button for like a half second. This is the left button. We're gonna have to press it for like a half second. So in order to read, we're gonna have to manipulate the switch from 0 to 2. Switch from 0 to 2 is going to show in digit 0 and digit 1, and this digit 1 corresponds to port P. And in order for the data to be read in port Q, we're going to have to manipulate the switch from 4 to 6. And from 4 to 6 is going to show the address is going to show in digit 2, and the memory address is going to show in digit 2, and the data is going to read in digit 3. So in order to do the operation for the ALU, we're gonna choose the P address by using the switch from 0 to 2, and in order to choose the address Q, we're gonna have to manipulate the switch from 4 to 6. And in order to make the operation, we're gonna have to manipulate the switch from 12 to 14. This is the switch from 12 to 14. 12 to 14. And in order to implement the operation, we're gonna have to press the left button for like a half second, and the operation is gonna show in digit 1. So in order to do this design, we're gonna have to do the instantiation for the ALU1, which is we're gonna have to use the button, the bones. We're gonna have to use the memory display to instantiate the memory display. Yeah, as you can see, and in order to implement the code, we're gonna have to finish the processor on the square GP. That's SV. We're gonna have to simulate after finishing the code, and we're gonna run this file, the lab12 that I top IO wrapper.tcl in order to get a bit file. And finally, when we got the bit file, we're gonna download it and save it into the USB key and plug it into the board in order to display the result. So in order to, this is the code, the processor or 20p that I made, that I wrote. So this is, I did the instantiation and all the stuff that we need for the design. Yeah, in order to download, this is the file that I download for the display. And when I download it, I got this file. This is the file that I download into the USB key. So this is the board. So I plug my USB key into the board and I connect it with the computer. So in order to show the results, so we were supposed to write the 8-digit. We were supposed to write the first 8 number of our TU ID to set the address Q equal to 3, P equal to 0, and to do the operation 010101. So this is the 8 number of my TU ID. So the address number 0 corresponds to TU ID 9, and in order to write this, like I said before, in order to write, we're going to turn the switch 7 on. This is on, and the switch 3 must be off. The switch 3 is off. So in order to write the address 0, we're going to have to manipulate the switch number 0 to 2. So since the address 0 corresponds to 9, this is 0. The address 0 is going to show here in this 0, and in order to write 9 in digit 1, we're going to have to manipulate the switch from 8 to 11. This is from 8 to 11. So in order to write 9 is 1. 9 is 1. 9 is 1009. So 0 is the address which is storing in digit 0, and 9 is the data which is storing in digit 1. So in order to save it, we just need to press the button left for like a half second. So it's safe. So in order, we have to write all this into the memory. So we're going to continue with the address 1. Address 1 showing in G0, and 1 correspond to TUID 1. In order to write the TUID 1 in digit 1, we're going to have to manipulate the switch from 8 to 11. So 1 correspond to 1 is 0001, 0001, yeah. So this is 1, so we have to save it. So we're gonna continue. 2 correspond to 5. 2 correspond to 5. So 5 is 0 1 0 1. So it's 5. So we're gonna have to save it. So let's continue. 3, address 3. 3 is correspond to 8. 8 is 1000 10 1000. Yeah, 1000. So we're gonna have to save it. So the fourth one correspond to 9. So 9 is 1. 9 is 1 1 0 0 0. So the address 4 correspond to 9. So let's save it. So the address 5 correspond. The address 5. Let's write 5 first. 5 correspond to 7. 7 is 7. Save it. So let's say 6. RS6 corresponds to 7, so it's already 7, so let's save it. RS7, let's say corresponds to 7, so it's already 7. Let's just save it. So we're going to check if the board is able to read all this data that we just wrote. So you're going to turn all the switches off, yeah. In order to read, switch 7 has to be off, and switch 3 has to be off. Sorry. So we said earlier that data 0 was corresponding to 9. So it's showing 9, and it's showing 9 in address P and address Q. Let's continue with 1. Address 1 is 1. So it's reading 1 1 in port P. In order to make it read in port Q, we have to manipulate the switch from 4 to 6. So we say 1, right? 1, yeah. 1 is 1, so everything's work. So let's try another one. Let's try number 2. Number 2 is 5. It's 2 corresponds to 5. It's showing in port A. So if we wanted to read in port Q, we have to manipulate the switch. Yeah, it's showing. So that means the board is able to write and read. So the code works perfectly. So we're going to process with the ALU, the arithmetic logic unit. So in the lab, we were assigned to do the operation for the 0 1 0 and the 1 0 1. So in the lab manual, this is actually the lab manual and the explanation of the switches. In the lab manual, 0 1 0 is if A plus B with no carry, and 1 0 1 is A plus 1. So we're going to do that. So in order to do the operation, we go to the ALU. We're going to have to turn the switch tray on and turn all of them off. So this one. So we're going to, for me, I'm going to make 0 in port Q, in port P, and 3 in port Q. So in 3 was corresponding to 8, and 0 was corresponding to 9. If you want to do the operation 0 1 0, it's going to be A plus B. A plus B is 8 plus 9. 8 plus 9 is 17, and 17 corresponds to 1. So we're going to check if the board is able to show 1 after the expiration. So 0 1 0, we're going to do that here. In order to do the exploration, we're going to have to manipulate the switch from number 12 to 14. So we say 0 1 0, right? 0 1 0. So this is 0 1 0. So in order to do this operation, we're going to have to press the left button for like a half second. So let's see. Oh, it's showing 1. That means the design worked. So we're going to do the same thing for 1 0 1. The operation 1 0 1 corresponds to E plus 1. So we're going to make sure that we have the same design. So I'm going to write the address 0 again, because so I'm going to save it. So in order to do the operation, we're going to do P equal to 0 and Q equal to 3 again. So for Q equal to 3, we're going to have to do that. So in order to do the operation 1 0 1, we're going to have to manipulate here from 12 to 14. From 12 to 14 is 1 1 0 101. 101, we just did it. So in order to make this operation, well, we're gonna have to press this. So 101 corresponds to 8 plus 1. So this is supposed to show like 9 plus 1. 9 is a 9 plus 1 is 10. So it's supposed to show here a because it's in hexadecimal form. Let's see if we got it right. Oh no, I forgot to turn the switch. You see, when you for the ALU you have to turn the switch trade or on. If it is not on, it's not going to show anything. So that's the thing I forgot. So I'm going to turn it on. So let's see if it's work now. Yeah, it's work. So it's A. As we can see, that means the ALU, the rate, the true rate and one, right? Memory just work. So the design, this is how we design the processor data path. Thank you so much. As I said before, my name is Chanel. Don't get I am an electrical and computer engineer at Temple University. Thank you so much. Bye bye.